Hello everyone, this is Debapriya and welcome to the Product School webinar series where we discuss different ideas and learnings about the product management function. In today's talk, I will share my insights about how to lead AI incubations from PM's perspective. So, who am I? My name is Debapriya Basu and I am a principal PM at the Zillow Group. I lead AI for user understanding initiatives in Zillow Group. Prior to this, I have spent quite a bit of time in different products in Microsoft like Search, Azure, M365, leading different incubation efforts. So in today's talk, what I'm going to cover is basically the journey of an AI ML PM using real life examples to illustrate. And the journey or the mindset starts from when to use AI ML to solve customer problems. So we start with the mindset, we start with understanding when to use AI ML. Then we'll progress to a generic PM framework for incubations involving AI. And finally, we'll close the talk with discussing some skills that helps PM succeed in this role. And in the course of this talk, I'm going to interchangeably use AI and ML because artificial intelligence is broad, ML or machine learning is a subpart of it, but a lot of the efforts and the incubations that's happening in product and technology is happening in the ML space. So through the course of this conversation, I'm going to use those words interchangeably. So without further ado, we'll start with when to use AI and ML. Again, we start from the basics. This has nothing to do with being an AI PM. Like any good PM citizen, start with the customer problem, identify it. What is the problem? Can the problem be solved without AI ML? How can AI ML add value? I think these are the questions which form the foundation of the incubation. So here, let's consider Z-estimate. So Z-estimate is an estimate that Zillow AI provides to end users about the estimate of their home. Can this problem be solved without AI? How were people doing it before AI came into the picture? So people who wanted to buy or sell homes or rent homes would go to their agents. The agents would give them an idea about what the estimate of the home would be. And that is how they solved it in the pre-AI age. What value did AI bring to the table? Couple of things for the customer. First thing, easy access to information. You don't need to go to an agent to know the value. Second thing, identifying complex patterns to predict outcomes. There are so many complex factors that play into the real estate pricing, like location, like walkability score, like feature of the house. And these factors grow more in size as the time progresses. So AI helps identifying all those complex patterns to predict outcomes. Similarly, what it meant for the user was that they now also understand why a certain house is priced in a certain way via Z-estimate. And it gives them a good comparison tool when they are talking to their agents. There are some other very good uses of AI where AI is adding value, like AI adapts outputs to inputs in real time. What that means is AI learns in real time and personalizes the output based on the input that the user has given. AI scales on vast data sets really, really fast. Like identifying disease sequences in the DNA sequence using AI is a hot research area currently. Again, like I said, it enables personalization. It also adapts to post-launch improvements. So basically, not only does it react to user input in real time, it also reacts to user input after a feature has been launched. So the UX AI interaction, the flywheel keeps churning back and forth, thereby training AI to get better and better and better. So we'll consider a couple of cases where AI ML is in action. Let's start with predictions. We talked about Z-estimate. Like I said, Z-estimate is a very powerful AI tool for predictions. It incorporates multiple data models, and it responds to factors like neighborhood details, home facts, listing price, popularity on Zillow, and all of this becomes more understandable to the user. Now the user knows why a certain house is priced a certain way. Then recommendations. We all see recommendations everywhere in our lives as we interact with different shopping giants like Nordstrom. It also bleeds into recommendations in Spotify, Netflix, everywhere. And personalized recommendations is the value that AI brings to the table. Then classification. Take this classic example from Microsoft. It's called Focused Inbox. It helps determine what emails are of focus to you, and it suggests that these emails might be important for you, for your attention right now. So that's a classic classification problem. Natural language processing, one huge area where AI is being used again and again. Take this example. At a glance, here is a Microsoft feature whereby key points from a document are identified and shown to a user so that the user can read through those key points and triage the document even without going through the entirety of it. Anomaly detection. We all use spam detectors in our emails in everyday life. Similarly, conversational AI, another very hotbed. This is one area where a lot of research is happening. A lot of companies are investing. The reason being, it provides a intuitive, easy way for users to get targeted information from the system. And businesses also get a wealth of user data and user attention, which helps them build better systems and better solutions. Moving on, the next thing that we'll cover is what are the different kind of business outcomes AI strategies can drive. And this is one of the things that you should always keep in mind as you define a strategy around using AI. So the first business outcome, everybody knows about search, whether it's Google search, Bing search, everybody. Now, AI-powered search brought so much of productivity value to end users that it entirely ended up changing their human-computer interaction paradigm, and it became table stakes. So now you have AI-powered search everywhere, from Netflix to Spotify to Nordstrom. Just about everything has a well-powered AI-powered search engine behind it. So that's when sometimes the power of search is such that it has become table stakes everywhere. Next one, customization, personalization. Everywhere you look around, recommendations, custom personalization, which means basically personalization to segments, conversational AI. Every company is doing this. Why? Because they want to engage and retain the users. They want to understand the users, give them value at the point of time when they want value. Like Netflix artwork, it's actually personalized to individuals. So if you and I are being shown the same movie in the recommendation, there's a very high likelihood that we are seeing different thumbnails. Another one, AI helps identify insights that help businesses optimize their business goals, like saving costs or deciding where to invest. this example that I show here is where Google used DeepMind's ML to monitor and identify the areas where there was high power usage in their data centers. And using those, the patterns that they found out, they were able to reduce energy to cool its data centers by 40%. That's like huge savings. Similarly, one other thing is an AI strategy helps businesses expand to newer surfaces, expand to new customers, and do it quickly, do it well, because AI inherent has that concept of feedback that comes into it. So it's easier to learn with AI. This example here, Google search is well known. It's part and parcel of our lives. Google took it further. They expanded it to enterprise content. They expanded it to different surfaces, Gmail, Drive, Docs, Sheets, Slides, everywhere. Now you have the power of search at home, in office. You basically are carrying your same human computer interaction behavior into your workplace, and that's helping you as a user improve your productivity and making you stickier to Google products. This is a strategy a lot of companies like Google, Amazon, Microsoft, Facebook, Netflix, Zillow, everybody employs. And so it's very important to understand how an AI strategy can help drive business outcomes. That's super, super critical. With that, I'll move to the next part of this presentation, which is around a PM framework for AI incubations. What are the things that you need to keep in mind? If you're starting from scratch, it might seem overwhelming. So where do you start from? Yes, you've started from the customer problem. You've figured out if your problem needs can be enhanced using AI. You've now looked at what's the strategy. Now, how do you actually get into execution? There are a lot of stages, and I've tried to couple stages which are similar and almost go hand in hand. So ideate, the ideation of the solution often goes hand in hand with identifying the data and the AI technology. Data is supreme in AI world. Understanding data is super, super important. Defining the vision is something that's critical to any incubation, any product launch, and same with AI incubations. Why is prototype clubbed with it? Because as you do prototypes, they help sell the concept to the stakeholders much faster than any textual or visual presentations. A big part of incubations and AI incubations is to get sponsorship. So I'll cover some things that I've learned around getting sponsorship. And with that, you have to build a team. An AI team needs specific skills, and incubation teams need specific attitude. When you marry the skill with attitude, you build a golden team. Then of course, UX is a very critical component of AI. Why so? Because AI is non-deterministic in nature. AI will not give you the same solution for the same input over and over again. How do you design for happy path? How do you design for the not so happy path? UX helps convey those messages effectively to customers. Architecture, without the backend system, without the backend end-to-end architecture, you cannot build a product. So that's why both of them are together. And then once you've done the prototype, there's a phase where you develop the model, and you take it and you get data, you get your metrics, and then you start working on developing the model and operationalizing. A big part of operationalizing it is experimenting it to validate the hypothesis, and prototype developing models and experiment and productionizing is often a cycle that keeps happening in iterations. And so that's why I've kind of tried to show that via arrows. What's very important in the AI world is two things. One is iterative learning and the other one is lateral thinking. And we'll cover these two aspects as we go through the presentation. With further ado, let's move on to the next one, ideate. What is ideate? Ideate is the ideation of the solution. Even if you, before going that, you need to align the stakeholders. In enterprises like Microsoft and Zillow, where you have a lot of different teams who work on the solution end to end, you need to align all the stakeholders to a common definition of the problem. Then you need to define the objective function. What is the goal of the AI technology? Is it prediction? Is it classification? Is it something else? Then you identify a hero experience. Particularly for prototype, we build AI technologies that can span across multiple surfaces, but for the prototype or the first launch, we have to always figure out the hero experience. Why is it important? It's important for two things. Does this experience move quicker? Are you able to prototype quickly here? The second thing is, are you able to learn? Are you able to learn from implicit and explicit user feedback on the UX? Because that's a very critical component of AI. There's the UX, there's AI. AI provides some suggestions which is shown to the user. User interacts with those suggestions, gives some feedback. That feedback flows into AI. AI learns from it, again, gives another suggestion. The user interacts with it. So this implicit and explicit feedback mechanism, implicit is when you just look at engagement or other interactions to learn. Explicit is when the UX has affordances where it asks, why did you not like something? Why did you like something? And the UX should be flexible enough to add in these implicit and explicit affordances for AI to do a better job. And that's why identifying the hero experience or the hero scenario and the surface is super important for kickstarting the incubation. Of course, success definition. What does success mean in terms of online metrics? Are you trying to drive more engagement? Are you trying to drive more visits, shares, searches? What is it that you're trying to drive? Online, I always recommend defining success in terms of online metrics because that has a direct relationship to customer value. And of course, then you have model offline metrics or model quality metrics. Those could be classification metrics like precision and recall. Think of precision like a measure of exactness, whereas recall as a measure of completeness. Carrying on. So there are other rank-aware metrics like normalized distributed cumulative gain that kind of speaks about relevance in search results. And then the final part is trade-offs. What I mean by trade-offs is for the same model used for two different use cases, the model quality metric that we pivot on may be different. For a cold start use case, when results are shown to the user a first time when he or she signs up, it might be that we want to optimize for recall. Vis-a-vis for a repeat user who keeps coming back to the site, we want to optimize for precision. Then let's take an example. This is a real life example from Zillow. Now, on the right in the picture, we have our UX, which we call the home details page. This shows us details about a user, details about a home that a user is clicking on. As you see, the price is there, the address is there, the Z estimate, and then there's this button called Contact Agent. So if you have questions and you want to contact an agent through Zillow, you can click on that button. Now, the problem that we wanted to solve here is how popular will this listing be in a few days' time or maybe tomorrow. So the way we define our objective function is we predict the likelihood of a listing to drive contact requests tomorrow, given details about the listing, like price, size, location, etc. Or historical engagement, like number of views, saves, contacts. The offline metric that we um, monitored here was AUC and NDCG. AUC, think about AUC, or area under the curve, as a probability of selecting a random positive sample over selecting a random negative sample. And again, the online metrics that we used here were number of contacts and number of views. I've attached the blog post about this work, but this is how you go about taking a problem and breaking it into objective functions, offline metrics, and online metrics. Now, one thing I want to call out here, which is super, super important, is this is not something that you will do as a PM by yourself, but you should have enough depth of understanding to be able to drive these conversations with your science leadership, with your engineering leadership, with your product leadership, with your organization leadership. So a lot of this ideation, the results of these ideation stage is a cumulative effort between the product manager as well as the science and the engineering leadership in your company. But as a PM, you're expected to drive it, and you're expected to influence it in a way that is going to be beneficial for the end user. The next very, very important part, identify data and AI technology. So here we have first-party data and we have third-party data, and there are implications of using both of them. So as a product manager, one of your very important things is to identify what data are the models going to be trained on. Are those first-party? Are those third-party? Are there privacy and security concerns around using those data? In a future slide, I do cover the concepts of ethical AI, which I think is super important as we think about building AI models. Other important things about data, is it fresh? I mean, you don't want to probably build a model which is over some data that was collected 20 years back. The data should be unbiased. It should be representative. So similarly, it should be relevant, meaning that if there is data that's missing, or there's noisy data, or inconsistent data, or duplicate data, all those things should be taken into account in the pre-processing of the data, so that the final data set on which the model is built is, again, fresh, unbiased, representative all of positive and negative samples, and relevant. In terms of the technology, at this point, there's always a conversation about which AI technology to use. So you have, of course, in this conversation, I'm going to cover machine learned technologies. So machine learned has, again, different types. Supervised, you have a labeled data set, positive labels, negative labels, and the model learns from it and predicts. Unsupervised learning, the model has no or does not get any labeled data set. It tries and identifies patterns from the data. Reinforcement learning, this is a hybrid between supervised and unsupervised, in the way that it starts with a limited data set to start predictions, and then it relies on actual user feedback that's coming to the model suggestions, and uses that feedback, both implicit and explicit, to retrain the models and learn, for the models to learn. So which one will you pick up? I think there is a lot of conversation that will happen with your science and engineering leadership on this front. There are different modeling techniques. You have deep learning techniques, which is basically using a neural network with more than one hidden layers to do some kind of learning. You have NLP, which is natural language processing. Sentiment analysis, keyword generation, language disambiguation, entity recognition, all of that falls under natural language processing. Ensemble learning, again, random forest is an example. Sometimes instead of doing only one kind of model algorithm, you actually use a bunch of model algorithms for maximal accuracy. So as a product manager, you should be aware of uh, of these concepts, and also you should know why a certain technology or a bunch of technologies are being used to solve the problem. There's also the question of pre-trained models. Now, if you want to ship something really fast, maybe pre-trained models is a solution to go. If you want something with very little room for error, maybe starting out with pre-trained models is a good way to approach that problem. So as you understand, even in the ideation phase, as you are developing the problem, the objective function, the availability or the non-availability of the data makes a huge difference, because it's super critical uh, to the modeling work. The other part is what technique you use is also going to impact on the timeline of the project, on the model uh, on the model quality, the model suggestions. So these two things go hand in hand. The next one, again, is around defining the vision. This is super critical, because you have to start with defining the value proposition. What is value proposition? It's nothing but an articulation of the benefit to the customer. Like summarization helps users triage content effectively. User understanding AI helps um, understand and predict customer behavior for deeper personalization. The next phase of the vision is surfaces. How many surfaces can it go out to? Summarization can start with documents, can be expanded to blogs, can be also shown to emails. How do you expand? What are the different surfaces? With that, at this point of time, it's very beneficial to do a crawl, walk, and run, because you're not going to solve everything in one day. So break it up and decide what is the crawl state. And oftentimes the buy off happens on the crawl state first. At this point, you also want to define the long term success. What does long term success mean for this technology? For summarization, you would say, or user understanding, you could say my long term success is adoption on different surfaces. What's the metric? Um, what's the online metric that you want to care about here? The online metric here for summarization could be the amount of time saved by an end user, because the summarization helps them triage. So all of these should be part of the vision. With the vision, the next very important thing is the prototype. Now, as you can see, that vision and prototype are kind of building blocks that you use to pitch an idea, sell an idea, get sponsorship. So prototype is a very important phase of it. How do you start prototype? You start by looking at the data. You look at every attribute of the data in isolation. You look at relationships between different attributes in the data. You analyze the data in context of time, users, and other entities. And then you visualize. What you're trying to do here is to identify patterns. That's super important in any AI incubation. Next part is building. You simplify an objective function, like whether it's predicting the number of saves or visits. You select the most relevant features. And then you start testing multiple algorithms if needed, as part of the ensemble learning that we discussed. Now you have to remember that this part is not often time bound, and it may not yield the best result in the first iteration. So keep that in mind. And so there is a very trial, try, iterate until you hit a certain criteria phase that happens in the prototype, which can frustrate a lot of people. But for folks who love doing incubations, that part is super exciting. Like, I become very super excited about that part of the process. And it's a good color. It's something that you have to keep in mind. The next part is validation. If you're using supervised learning, validate offline metrics against ground truth metrics. If you're using unsupervised learning like clustering, determine how well apart the clusters are, how well a point is situated in a cluster. And don't forget the value of eyeballing. Always eyeball. If you are trying to identify keywords from a document, look at the keywords that AI extracted and see if it makes sense to you. Like, start with that. That's super important. And then the final part is define an acceptance criteria, define behavior in edge cases, define fallback if the model does not work as you thought it would be, and iterate till the acceptance criteria is reached. And keep in mind, when you define the acceptance criteria, what are you improving on? Are you improving performance on an existing non-AI solution or an existing AI solution? Because your acceptance criteria will differ significantly. And then do this in a cycle. Now that you've got the building blocks in place, you've got an outline of the vision, you've got an ideation of the solution, you've got data and technology aligned, you've got a prototype. Time to get sponsorship. Now is a very crucial part of any incubations, and AI is no different. You have to sell the product and the tech vision to your leadership, or your whoever is sponsoring that effort. Couple of things to keep in mind as you go about this exercise. Try and outline the ROI in terms of either monetary gain or in terms of the users you acquired, retained, cost that you saved, or you might have company OKR, so you know your company KPIs, what are the gains and saves on those KPIs. Then what's the value that this technology is bringing to end users? Is it productivity? Is it increased engagement? What is it? What is the value for the business? Like, does this technology align with the overall strategy of the business? What are competitors doing in that space? What are you providing a differential solution? So have all of that information in your plan when you go to pitch your idea to get sponsorship. And the final part is resourcing. How many people would you need? What type of skills do you need them to have? Things like that. This is super critical in getting sponsorships, and even in enterprises, this is a big part because like I said, an AI solution spans across multiple teams. The UX may sit with one team, the AI may sit with another team, the architecture or the pipeline can be powered by a third team. So you need to get buy-in from all of those stakeholders, and in order to proceed to build the end-to-end solution. Then is building a team. So let's assume you get sponsorship. How do you build a team? What are your immediate needs? Of course, you need applied science, people who do the modeling, data science, people who understand the patterns, understand the data pipeline engineering folks, end-to-end and online product engineering folks, machine learning engineering folks. These are the skills. Again, you need to form your V team because you might need annotators who label the data. You might have to work with experienced teams, people who own the UX, or people, if you are working on devices like Alexa or Google Home or Cortana, you have to go and talk to those experienced folks. You need to get sign off from the architecture team, your data engineering team, experimentation platform team, of course, legal, privacy, security, super important. I cannot emphasize the importance of them while you build AI tools. These are good skills, and these are the different folks that you'll reach out as you bring together your folk or your crew to build the incubation. But one very important part here is the attitude. I think incubation needs a slightly different attitude. There has to be comfort with ambiguity. There has to be willingness and ability to shape the problem in different ways, ability to look at them from different angles, different dimensions, think laterally, and having the mindset that success comes in iterations. It will not be that I built something and it's successful. No, everything is a build, test, validate, launch, iterate. And so having that attitude, people who are okay with that dynamic attitude do wonderfully in AI incubations. The next part, like I said, is around UX. UX plays a very, very big role in AI. AI is non-deterministic in nature. AI will some days give suggestions with a lot of confidence, some days will not give suggestions with a lot of confidence. How does the UX make it easy for users to understand that? How does UX make it easy to explain AI to end users? Super, super important. So take the first one. Even before I go there are two parts of feedback. There's implicit feedback and there's explicit feedback that a user gives. And implicit feedback is through engagement, is through dwell time. Explicit feedback is when users actually tell, I don't like this, or I like this. I don't like this because. Understand, implicit feedback is super critical to building better AI models. With that being said, I'm going to walk you through some examples where AI, the UX has made the AI easy to explain and transparent. The first one, Z-estimate. It clearly tells that the Z-estimate incorporates multiple data models and respond to factors like neighborhood details, home facts, popularity on Zillow, listing price. What this enables is users who look at Z-estimate now understand, oh, these are the factors that make the price what it is. Okay, I now feel that I know a little bit better. So that enables trust in their minds, which is super important. The second one is around data sources. So in data sources here, here's a list of recommendations shown on Amazon. Now, the fact that Amazon is saying that customers who view this also viewed says that you're part of some segment that Amazon has figured out who are interested in these documents. Telling that or conveying that to the users is very good, because now you know that why am I shown these recommendations. Similarly, North Face here shows the match confidence. So like green is something in which they have very high confidence that this item is suitable for the user. Red is something where they call it a low match, they are not that confident. And yellow is somewhere in the middle. So what Nordstrom is, North Face is doing here is it's enabling users, it's explaining to users why they are showing something. And so users would know which of these recommendations to pay more attention to and why. This is the explicit feedback is something that's used across the industry. YouTube uses it in like, dislike. Here's another snapshot of explicit feedback UX from Facebook. When you dismiss an ad, this is what they show, and this is how they learn why you are not interested in a certain ad. So when you think of AI and you think of an AI incubation, pay a lot of attention to the UX and work with your UX partners to ensure that the AI which is powering the UX is explainable, and your UX partners are your biggest friends here. They are the experts and they will help convey that message to users. So UX super important for AI. Next one is AI architecture. Now this is very interesting. Of course, like any system that we build needs an architecture. AI has two extra things that come into play. One is the offline model training pipeline. So you do need to build an offline model training pipeline. And the other one is the online serving infrastructure. This is specific to AI models. As a program manager, what are your considerations? Most of this design of architecture will happen with your science leadership, with your engineering leadership. But as a PM, what are the things you should keep in mind when you go into those discussions? What's the mechanism of data collection? Is it batched? Is it streamed? What's the frequency of data collection? What are the dependent systems? How are predictions processed, in whether it's in real time, whether it's in offline? These considerations have immense impact on the way the system is designed. I've added a link to a wonderful system design paper for AI recommendations used by LinkedIn for your read. And these are the actual pipelines that they use. It's a wonderful read if you want to get into the details of AI architecture. Moving on, now that you've done all of that, so the design work is all done, now it's time to execute. So for shipping a model, what do you do? Well, you refine prototype or build new models. So of course, again, a lot of things that you do in the prototype stage, again, happens here. Data analysis, algorithm selection, objective function selection, training test set selection, feature selection, expanding data coverage, checking for outliers, retrain, retest, scale to new markets and languages. Super important if you want to, if you're building a model for a natural language, an NLP model, and you want to take it to a new market, which is still an English market, there might be some nuances to way people in UK speak vis-a-vis people in USA. So how do you scale to the new market and understand those nuances? What if you want to, what if you started building your model or your first version is in English and then you want to expand to Spanish? You have to start looking for Spanish data sets. So a lot of these considerations keep coming in where the product manager is expected to identify and provide insight. Similarly, on the operationalization part, the first and most important thing is validation using online experiments. How do you ship in production? How do you learn from causal uplift analysis, scale data collection, scale models to new markets and languages, incorporate feedback, reduce friction to deploy models, version controls models. As a PM, you might not be doing all of this, but have it as a checklist. Ensure you have the conversations with your science and engineering leaders that each of them are done. I have this checklist in mind as I go into conversations in the execution phase. This is to ensure nothing is missed. And what does success look like in this execution phase? Success is through online metric improvements and offline metric improvements. So this is super important. Treat this slide as a checklist of the things that you need to keep in mind in the execution phase. Moving on, what is the sustained success criteria? What I mean by that, there can be different kind of AI AI incubations. The first is where you have a specific product or a feature and you're building an AI model to power it. In that case, what's the sustained success criteria? It's an established relationship between the online metric and the offline metric. So, does increasing the precision of my prediction increase the number of visits to the home details page? That's the sustained success criteria. Now, there's another category of incubation where we are trying to, let's say, build an inference platform, meaning you're trying to understand different uh, a class of entities, and you're using different models to do that. In my case, user understanding AI is a class of models that help understand a customer state and segment and journey. And what does success look like for that? It means adoption. It means adoption by different analytics teams. It means adoption by different product teams. It means adoption by different marketing teams. So understand what is your sustained success criteria. And that is super critical, because once you understand what's the success criteria, you can optimize for it. Then, very, very important, ethical AI. AI has in the past proven to have biases, and it's our job as product leaders, as people working in this space, to ensure that AI respects privacy and is fair to everyone. Now, for the privacy aspect, researchers they were able to identify actual Netflix users by correlating their anonymized test data provided in a Netflix price competition with the publicly available IMDb movie review database. That's a big no-no for privacy. And so much so that Netflix discontinued this price competition. So AI models should be built within guardrails to ensure that users cannot be identified or their details inferred from model output. Similarly, for fairness, models used for making decisions or predictions should not be biased with respect to attributes like race, gender, sexuality. Also, interaction bias, selection bias. What does it mean? Interaction bias means that the system should not learn only from people who are heavily interacting with it. And it's happened with chatbots learning abusive words from use of Twitter. Or selection bias, which basically means that some set is more represented in the training data set, which leads to that that category being predicted more. So we've actually have had cases where recruiting automation algorithms suggested more males for job applications just because the training data set had more male. So, like Joy Adoa Boalam Winnie, she's doing amazing work in as part of the project Gender Shades, and here she uncovered that facial analysis technologies had a heavy bias towards white males. Precision for white males was 99%, and accuracy for white males was 99%, while that of females was a mere 35%. Once she brought it out, when she brought this out, companies acted around it, and that made and so there's ongoing work that's making facial analysis technologies less biased. So understand the implication of what data you use and how you are using them. Ethical AI is going to be a guardrail that helps AI scale better and be more useful to mankind going forward. The next thing that I cover, this is kind of the last part of my presentation, which is the skills which I think help AI PMs succeed. First thing, ability to zoom in, zoom out to guide product direction and discussion as needed with your technical stakeholders, zoom in to align product to broader business strategy, focus, keep an eye on customer problem at all times. Like you'll get into so many decisions and meetings where people will say, oh, I don't have data, oh, I need to do this for the sake of science. Keep in mind what is the customer problem that you're trying to solve at all times. Refine the optimization function, the online metric. Try to be as crisp as possible. Uh, and also the offline metrics until you found out a relationship between online metric and offline metric, right? So keep iterating on these definitions. Clarify. What I mean is clarify goals, assumptions, understand what the data says, look at data, learn, look at the insights, and then simplify the problem, the process, the solution. The more you simplify, the better better chances you have to succeed. And finally, super important, be resilient. Incubations come with failures at every stage. Things don't work, you keep on trying, don't take it to heart. Course correct, reshape the problem, remodel, re-engineer, think laterally, but be resilient. Success is a process, not an end goal. Nothing other than incubations will teach you that better. And I think if there's one thing you would take away from this presentation, take away this mindset that for AI incubations, you have to be resilient, and it's completely doable. Then, moving on, what's next after a successful incubation? So you've launched something, you've validated offline metrics, you've figured out a relationship between online and offline metrics, your A/B tests look great, you shipped the product. What next? Study user impact, analyze what users are saying about your feature or your product, analyze what are their pain points, whether those are UX pain points or whether those are AI suggestion pain points, work, mitigate them. Work on a strategy for improving your model quality, whether it's with fresh data, feedback, train on sophisticated frameworks like BERT, use more data, build a strategy. And then build a product and technology strategy. What I mean by that is once you launch something, understand, analyze what industry and experts are talking about it. What are their sentiments? What's the product ROI when you expand to surfaces, new markets? Does the engagement and feedback funnel provide enough data to retrain models? If not, do you need more data? How do you get new data? And is the UX good enough? Does it need to be updated to ensure better model quality? Look at all of this. So your job doesn't stop. These are all the things that you have to keep in mind. But then there's again a question of what's next. Like after you've done all of this, you look and you say that what is it that I want to do? Should I take this ship technology to the next phase, meaning I make it a more stable technology, a stable product, or do I move to shape a new idea to solve a new customer problem? And it depends on what you want. But that's when have that discussion and with yourself about what you want to do next. And finally, how is leading an AI ML incubation different from leading any other projects? At the foundation, you have the core PM skills. You can't do without those. Standard core PM skills, understanding customer problems, strategy, vision, success criteria, drive alignment and collaboration, execute. The next layer, AI PM skills, understand AI, technology, process, needs of building models, define the optimization goal, understand data sets, UX, understand privacy legal implications, do all of that. That's super important. Then you have incubation skills on top of it. Shape a problem from ambiguity, find stitch data, learn from insights in the data, envision, convince others about your vision, collaborate. Think laterally, think iteratively, reshape, repivot, rebrand as needed, and be resilient. To summarize, AI PMs need a heavy measure of entrepreneurial mindset uh, to lead successful incubations. Core PM skills are super important, so are AI PM skills, and only when you have this pyramid of skills are you able to um, go through the process of an incubation from start to finish successfully. Before I conclude this presentation, I want to give a special call out to all my friends and colleagues whose input and comments helped shape the content of this session. And the key takeaways or the food for thought that I want you all to take back and think about after this session is, when do you use AI ML to solve customer problems? What are the stages you as a PM go through in the incubation? And what skills and mindset will help you to succeed in these incubations? I would love to know your thoughts, your experiences, your comments, your ideas. Please feel free to reach out with your thoughts and ideas. And thank you, Product School, for providing me this wonderful opportunity to share my learnings and insights. Take care and stay safe.